This is conversions and dimensional analysis. So we're going to go back and revisit our conversions and actually work problems with them. So the process we're going to use is something called dimensional analysis or unit conversion method. There are a variety of ways to work problems. A lot of you have probably used the ratios, and I started doing this with the density, but you could do the density strictly with a ratio. But the problem is that's fine if you only have one step, like in a density. But if you're using the density along the lines of something else, and you have several steps inherent, then you have a problem with the conversions if you don't do something else. Now, the way this works is basically to keep up with your units. Okay, this is keeping up with your units, because what happens is that, so I always start with where I'm going because I tend to get lost in my problems, and I'm going to start with the amount given, which in this case is cups. Well, I need the cups to go away, so I want a conversion here that allows me to cancel the cups. Then I do fluid ounces to milliliters, and then milliliters to liters, and liters to kiloliters. So the net effect is following my units. I haven't done anything with my numbers. I can get where I need to go. Now, why is this an advantage? Because I haven't done physics in ages. But if you brought me a problem and I had the units and I knew what units I had and where I was going and some conversions, I could get there. It might not be pretty, but the units will tell me where to go. So, useful conversion units between the unit English and metric are found on the back cover of the text. You will be given English to metric conversions on the formula sheet you're given for the test, but all the metric you're responsible for. So, we're going to look at several of these as we go forward that have already been worked, and then we're going to work several. So, and when you first start these, it's not really comfortable. And by comfortable, I mean some of you are like, I've never done it this way. Well, that's fine. Do I have to do it this way? Pretty much, because this really is the easiest way, and it's a matter of getting into the rhythm of it, because as the problems get a little more complex, this sets you up to already be thinking about your units. Okay? So, again, we're following the units. If you notice, they're canceling all the way down. So, if you do this right, whatever unit doesn't cancel is the one that you were looking for. Now, there are multiple variations to this method in terms of the conversions. So, for example, on this one, I think we changed this one and this one. On this one, that should be a minus 3 liters. This one changed and this one changed. But notice that the conversions are the same. You're just looking at them differently. Tomato, tomato. On this one, we changed the cups to pints, pints to quarts, quarts to liters, and a liter to kiloliters, etc. And notice that using significant figures, it doesn't matter which way we do it, your value comes out to be the same. The only time this doesn't work is if you make up conversions. Don't make up conversions. That's a bad idea. All right. And remember, English metric conversions I will give you. You are responsible for the metric conversions. So, let's look at some conversions. Now, there's usually more than one way to do this. So, for the first couple, I'm going to show you a couple different ways to do it. But then I'm usually going to go and do it one way. If you choose to do a different way and you get the same answer because you've used comparable conversions, then no sweat. All right. So the question is how many millimeters are there in that many yards? So that's what I'm looking for. I'm going to start with the amount given. And as I said, there are a couple ways to do this. First way I did it is 1 yard. is equal to 3 feet. 1 foot is equal to 12 inches. And 1 inch is equal to 2.54 centimeters. And I know that 1 centimeter is equal to 10 millimeters. So when I go to do this, I start by, you can multiply all on top and divide all on the bottom. Be careful of order of operation. I do them individually. So what I would do is take 0.52 times 3 divided by 1 times 12 divided by 1 times 2.54 divided by 1 times 10 divided by 1. Now, do you have to divide and multiply by 1? No, you can skip those. But gives you a value of 475.488 millimeters. We're doing millimeters. Okay, so if we go back and look, this is two significant figures. This one is infinite. This one is infinite. This one was an exact, so it's infinite. And this one's metric, so it's infinite. So we will report it in two significant figures. So it's going to be 480 millimeters would be my final value. All right. Another way to do this is I'm still looking for my millimeters. Still starting with the 0.52 yards. But this time, I happen to find the conversion that says they're 1.0936 yards in 1 meter. And 1 meter is 1,000 millimeters. So that means when I run the math, I get 475.49378 millimeters. Now, notice that these are mostly the same, but after the decimal, they start to change. Does it matter? Again, we're going to report it as two significant figures because here's two significant figures. Here are 1, 2, 3, 4, 5 significant figures. And here are infinitely many, so it'll report it as 2. So again, we end up with 480 millimeters. So see, it doesn't matter as long as you don't make up conversions. You start making up conversion, all bets are off. Okay? So next one we're going to move on to is we want how many milliliters are there in 12.5 ounces. So there are a variety of ways to do this. The long way, we could say there are 32 fluid ounces. And the ounces are annoying because you have fluid ounces, you have weight ounces, you have a jewelry ounce, a troy ounce, which is in jewelry. So it kind of makes you crazy. So be careful of your ounces. That's 1 quart. There are 1.0567 quarts in 1 liter. 1 liter is 1,000 milliliters. Again, everything on top is multiplied, everything on the bottom is divided, so you end up with 369.66 milliliters. If we look at it, we have three significant figures. Here we have infinitely many. Here we have 5 significant figures. Metric, so infinitely many. So we were going to report it in 3 significant figures. So it comes out to be 370. Wait a minute, that's only 2. So I would put a decimal place behind that 0. So because that indicates that that 0 is significant. Now, some of you on this one especially might have seen, hey, wait a minute. There's an easier conversion. And there is a much easier conversion. 8 fluid ounces, which is 1 cup, is equal to 236.59 milliliters. If you have a cup of soda, that'll show you that one. And so you end up with 369.671875. And again, it starts to vary after the decimal, but that's okay because, again, this is 3 significant figures. This one, the bottom has infinitely many because that's exactly 8, and this is 5 significant figures again. So report in 3 significant figures, which means you come out to 370 again. Again, you can use any conversion that's legal. You're not allowed to make up conversions. I cannot stress that enough. And the reason I stress that is because obviously people have done it. Don't do that. All right, so here we go. We've got a weight in kilograms. So we need it in kilograms. So 135.4 pounds. And this is one where the two conversions that are easily found are 2.2046 pounds is equal to 1 kilogram. And the other conversion that's easily found is 1 pound is equal to 453.59 grams. And that seems to be a favored one. So 1 pound is equal to 453.59 grams. And I know that 1 gram is 10 to the minus 3 kilograms. So that gives me 61.470 kilograms. All right, we have 4 significant figures. We have 5 significant figures. We have infinitely many because it's metric. So we would report this as 4 significant figures. So it's 61.42 kilograms. Okay. Now, I'm not sure why this one has truncated, but that's fine. On number 4, this conversion is strictly metric. So we start with the same number of significant figures. So we're going to start with 4 significant figures. So in all of them, we're going to end up with 4 significant figures. So if we're doing grams, we're looking for 248.6 milligrams. And 1,000 milligrams is 1 gram is equal to 0.2486 grams. Okay, and the next one is femtograms. Now, word to the wise, don't use the number you just generated, even though we're going to, as we go through it, we're probably going to use the same values. Because if in case you've typed something in weird, then you've gotten 2 wrong answers, redo it and make your life easier. So we're going to start with, again, the 248.6 milligrams. I'm going to say that 1 milligram is 10 to the minus 3 grams. And 1 gram is 10 to the 15th femtograms. So that means we end up with 2.486 times 10 to the 14th femtograms. Now, could you write that out with zeros? Yes. And on some of the problems in the D2L quiz, I might tell you to not use scientific notation. And other times, I'll tell you to use scientific notation. And it's truly a function of, excuse me, which case the questions are asked. Okay? So, here are a couple more. We're going to use deciliters. Start with 1.87 kiloliters. 1 kiloliter is 1,000 liters. 1 liter is 10 deciliters. So that puts us at a 18700 deciliters. We started with 3 significant figures. So we report with 3 significant figures. So if you want to avoid confusion, you could say 1.87 times 1, 2, 3, 4, 10 to the 4th deciliters. You don't have to, but you can. In terms of nanoliters, now that gets fun. 1.87 kiloliters. Okay. 10 to the minus 3 kiloliters is 1 liter. And there are 10 to the minus 9th liters in 1 nanoliter. And so that gives us a whopping 1.87 times 10 to the 12th nanoliters. Okay, and again, We kept 3 significant figures because that's what we started with. All metric, you keep significant figures. Okay? So this one gets fun. This one's micrometers. So first one is we're going to picometers. Now, you can go directly. I don't like going directly. So I'm always going to go back. So I know that there are 10 to the 6th micrometers per 1 meter. And I know that 1 meter is 10 to the 12th picometers. So that means it's 4.531 times 10 to the 11th picometers. Again, all 4 significant figures. All right, for the centimeters, again, 4.531 times 10 to the 5th micrometers. And if you'll notice, each time I'm doing this, I'm changing it up. 1 micrometer is 10 to the minus 6 meters. And 1 meter, where am I going? Oh, to centimeters. See, I keep forgetting. 1 meter is 100 centimeters. So, I don't need that tail. So I end up with 45.31 centimeters. Now, for those of you who like the scientific notation, you can do 4.531 times 10 to the 1 centimeters as you go. All right, this is the end of the chapter. Notice at the end of each chapter you have a chapter review, which has a chapter summary and key terms, the learning outcomes, and the key equations and the exercises. Also, for the exam, which is posted as to when it will occur, the study sheets will show what's on each exam. So I would start at the back of the chapter and then go to the study sheets as you study. And remember, you can rewatch these videos as much as you need to.